In this video, I'm going to take a look at just one more example for partial fraction decomposition. This example is going to include an improper fraction, so the first step will be to divide the numerator by the denominator, so then we can work with our proper fraction in the same way we did in the first three videos. Okay, so the big problem we have here is dividing the numerator by the denominator. Well, this denominator is a perfect cube here, so I kind of need to multiply this out first, so then I can work my division. Okay, so 2x minus 3 quantity cubed is going to be 2x minus 3 times the square of that, so 4x squared minus 12x plus 9. Okay, so whenever I work this, it'll be 8x cubed. Our square terms will be negative 12 and negative 24, so minus 36x squared. Our x terms will be 36 and 18, so 54x, and our constant is negative 27. Okay, so this right here is the denominator multiplied all out. So the denominator goes on the outside, and I'm going to work this division. So let's do it using long division, so x to the fourth, and then we have 124x cubed plus 238x squared minus 209x plus 77. Okay? And we can kind of ignore this guy here for a second. That was just our work. So what do we need to multiply by 8x cubed to make 24x to the fourth? Well, it looks like 3x. So I'll put him right there. And let's go ahead and multiply 3x through right here. And we should get 24x to the fourth. It looks like minus 108x cubed. Then the next one looks like a positive 162x squared. And then finally it looks like negative 81x. Okay, so of course with my long division algorithm, what I need to do now is change the signs. So I'm subtracting, so that's minus, plus, minus, plus, and here we go continuing on. So negative 16x cubed, when I combine those, looks like a positive 76x squared, a minus 128x, and then the 77 comes along for the ride. And let's do this one more time. So what do I need to multiply by 8x cubed to make negative 16x cubed? Well, just negative 2. So let's run that negative 2 through here. And it looks like negative 16x cubed, let's see, plus 72x squared, and minus 108x, and a positive 54. And of course I'm going to run through, change all the signs. Okay, so it looks like I'm left with that cancels, so 4x squared minus 20x plus 23. Alrighty. Okay, long division for polynomials. Yippee. Okay, so how can I now rewrite this improper fraction? Well, I can do it using the whole parts and the remainder. Okay, so I'm going to rewrite this as 3x minus 2. Okay. And then, of course, we have plus, and now 4x squared minus 20x plus 23 over my 2x minus 3 cubed. Okay? So now I have a proper fraction with which to work. So for now, I'm going to ignore this 3x minus 2 because he was just the whole part. And now I can get to work actually decomposing this into its partial fractions. Okay, so I see that I have a linear factor, and it has a multiple power here, or it has a power, so I have repeated linear factors. So I know that this is going to break down into, well, a over 2x minus 3, b over 2x minus 3 squared, and c over 2x minus 3 cubed. Okay? So I know here's my common denominator, so what's this one missing? It's the a times, well, I have one of them, but I need two more. And my b, it has two, but I need one more. And my c, well, it's already got all three, so I'm good right there. And that equals this numerator of 4x squared minus 20x plus 23. Okay? So my first obvious value of x that I'm going to use is going to be 3/2. Okay, because that'll cause this stuff to zero out. And let's see what that looks like. So this one zeroes out, this one zeroes out. So I have c equals 4 times, okay, 3/2 squared is 9/4 minus 20 times 3/2 plus 23. Okay, so c equals 9 minus 30 plus 23. C equals, it looks like, 2. Okay, very nice. Okay, so I'm going to find the values for a and b a slightly different way than I did in the previous videos, just for a change of pace so you can see another way to do this. So previously what I had done was just choose a couple more values of x, and then I would just plug those values of x in, and I would have a couple of equations with a and b, which would be a nice system, and then I just solve that system. But instead of doing that, I'm going to try another approach where I'm actually going to multiply this left side all out, and I'm going to line up the quadratic terms, the linear terms, and the constants so I can focus only on the coefficients. Okay, so just a little change of pace here, another method. So let's multiply this out. So I have a times 4x squared minus 12x plus 9. Okay, and then b times my 2x minus 3 plus my c, which is 2, and that equals that stuff right there. Okay, so I'm going to kind of put my quadratic terms here, my linear terms here, my constants here. So I have 4a x squared minus 12ax and then plus 9a. Okay, so quadratic terms, linear terms, constants. Those are my a's. Let's look at my b's now. So 2bx, so plus 2bx, and then minus 3b, and then plus 2. Okay, well, why is this nice? Well, because I can just pick up the value straight from here. This is 4x squared. This is negative 20x, and this is 23. So I know these two things are equivalent, these two are equivalent, and these two are equivalent. So looking at this right now, I can ignore my x squareds, and I can say that 4a equals 4. So a must equal 1. Okay? Well, if a is 1, let's go ahead and put it here. And then again, I can ignore all of these have x's. So I can focus only on negative 12 times a was 1, plus 2b, and that equaled the negative 20. Okay, so negative 12 plus 2b equals negative 20, 2b equals negative 8, b equals negative 4. And just to be sure, because I know I have my values here already, I can go ahead and plug them in. So 9 times 1 minus 3 times negative 4 plus 2, and it should equal 23. So 9 plus 12 plus 2. Yeah, that worked out nicely. Okay, so once again, instead of plugging in other values of x to kind of get this relationship between a and b so I can have a system and solve, I just did it another way where I focused solely on the coefficients. Okay, I grouped all my quadratic terms, all my linear terms, and all my constants, and then I focused only on the coefficients of each one. So the 4a had to equal the 4 here. This expression, negative 12ax plus 2bx, had to equal this negative 20x. That's how I set up this equation. And finally, with the constants, it was kind of a check just to make sure. I didn't really need that one, though. Okay, so I have values for a, b, and c. So let's go ahead and write it. So I know my whole parts from way up here were the 3x and the minus 2. So I'm going to say 3x minus 2, and now I can do my partial fractions. So my a was a positive 1, so plus 1 over, and let's see, 2x minus 3. My b was a negative 4, so I'll say minus 2x minus 3 squared. And my c was 2, so 2 over 2x minus 3 cubed. Okay? So here then is the partial fraction decomposition for this improper rational expression that we started with here at the top.